Welcome to the presentation of our case study on data-driven deployment of program analysis on an open tool stack. At the end of this session, I hope you'll get some insight in how we can utilize program analysis in somewhat a different way from what we are used to in our daily workflows. Program analysis is the term used for a group of tools which we use to find issues in code and computer programs. It will often be integrated with other tools that we use in daily development, such as editors and version control workflows. The benefit of using program analysis is that it saves us time, but in some cases it can actually do the opposite. As a matter of fact, static program analysis comes with a few very well-known usability issues, being false positive results, meaning the cases when the program analyzers are actually wrong about our code. And the presence of false positives leads to a lack of trust, and this means that also the true positives has to be verified, and this is a time-consuming process. Another well-known usability issue is when developers get flooded with results, and the process of filtering out the important ones becomes too time-consuming. So what do we do as developers when this happens? Yeah, we start ignoring the alerts at first, and then eventually we might actually look up how to turn the alerts off. A previous study, which has looked at Stack Overflow questions on program analysis, finds that the two most common categories of questions are how to ignore and filter program analysis alerts, followed by validation of false positives. A promising approach to deal with some of the usability issues of program analysis has been used at Google. They've developed an internal analysis system called Tricorder, which since has got a few descendants for special purposes. The general philosophy that these systems embody follows the following principles. So number 1, there shall be no false positives. Number 2, empower users to contribute. And number 3, make data-driven improvements to analyzers. Number 4, the workflow integration is really important. And 5, project customization is preferred over user customization. In this image, we can get the general idea of how data-driven program analysis works. And to the left, we got our developer tools. This is where we make changes to code and where the program analysis results are presented. To the right, we have some kind of ecosystem or platform or meta-analyzer system where analyzers are running and the results are produced. We can see here that there is also a feedback loop. From this feedback and the produced results, we can aggregate the data collected to gain insights on which analyzers are useful and not. The core goal of our research is to find out if we can replicate this approach of running program analysis in a new context, and if we can do it on an open tool stack. So in the Google context, there are like over 100,000 employees, and the source tree is huge. Also, the systems they use when developing are often internal, specialized and customized tools. And we try to move this code analysis approach to a smaller company with about 3,000 employees and a tool stack built up on open source tools with a core of Jenkins and Gerrit. We performed some key informant interviews in our new context and found that no systematic user feedback collection has been done before on the theme of program analysis. The strategy was instead to leave the decision up to the teams to do their own cost-benefit analysis on what would serve them best. But they were actually moving towards a more centralized model, where some analyzers were made available by a dedicated tools team that could just work in the build chain for the other teams. We also found out that at this company they had been kind of burned before by analyzers and had in some teams a strategy of picking analyzers carefully that were built for 0 false positives. Let's bring back this overview of a data-driven program analysis system to answer our question on how a system based on an open tool stack could look like. We ended up with a system that we called mean, like in meta-analyzer. Let's look at the design and the tool stack a little bit closer and draw some parallels to Google. You can see that we integrate the system with Gerrit Code Review, whereas they at Google integrated with a similar internal code review system. In both cases, a not useful button was added to collect user feedback. The feedback, together with analyzer results, was looked at to decide whether to put certain types of results on a blacklist. A blacklist was called a probation list in the Google case, but it's the same concept. And the program analyzers were running as Docker images in a Jenkins cluster. They were implementing a protocol which enabled us to configure all analyzers in one place, one file, on the same format. This made it easier for us as maintainers to keep the analyzer blacklist updated. If you'd like to know more about the tool stack integration or other specifics of the main project, please check out the repo linked below.
The deployment was done in 3 phases. We started small and then expanded to more developers. We started to deploy a system at the tools department. Then we included the streaming department, and during the 2 last weeks the system analyzed all code in the R&D department. The number in the parentheses showed the number of developers that was impacted. In this count we include every developer that was set as an owner or a viewer for code changes that the system analyzed. Answers that we tried to find related to the deployment was what effect deploying of the system would have, what is the level of user engagement, how many results are used, and what is the experience of the users and the maintainers. To find these answers, we analyzed data that we saved during the deployment, as well as sending out a survey. Here you see some count on how many not useful clicks we got per day in a log 10 scale. Around this time the system was deployed for streaming, and around this time it was deployed for the whole R&D. The blue crosses signify instances where we disable analyzer categories. We said that during the days where we got most not useful clicks, we also got enough data to disable specific categories. We disable a check when 5% of the published comments within that category was classed as not useful. There was some exceptions. Some categories was disabled early in the deployment, even though they had not got any not useful, because we considered that they would flood the users with too many not useful. An example is the category that checks that lines are not too long. We also tried to avoid disabling categories that had more than 5%, but overall had not produced that many comments at all. 52 of 407 users clicked not useful. Here we can see a distribution of what type of analyzers the user clicked not useful for. Each bar in this diagram represents one user. We see that most users click not useful on comments for 1 to 2 different analyzers. We also see that a few users contributed to many of the not useful clicks, especially for shell check and comment check. We estimate about 9% of the unique comments was fixed. This was calculated by taking the total difference between the first and last batch set on changes that was decreasing in comments. Then we subtract this with the number of comments that we knew was removed due to disabling categories. From the survey we found out that users thought that some comments was less useful because they were unrelated to the changed code. In this graph we see the not useful rate over time. This is calculated by taking the total number of not useful and divided by the sum of the total number of not useful and resolved comments. We can see that the not useful rate of piling decreases, which could be explained by the fact that we disabled some categories around this time. Some of the analyzers has a not useful rate that could increase even though we disabled categories for them, for example shell check. Reasons for this could be that it's still possible to click not useful on categories that is disabled. This system does not remove comments that includes disabled categories. It only prevents the categories from being included in no comment, which means that you need to upload the code again to notice that the categories has been disabled. In conclusion, we see that a data-driven approach to static analysis can be used at another company. We see results that points that it can be used to disable not useful categories, but the deployment was only done during a short period of time. By letting the system run for a longer time, we may get a different result, especially in terms of user engagement. Another thing to investigate could be about what results are used, or find a way to reduce noise for a better user experience. Also improving the integration by, for example, make it more apparent when a category already is disabled would be an option.
afternoon again. We have the three of the authors of the fourth paper for this session. This question answer session will conclude the session I will share now. We have Emma, Anton, and David that are all here to answer your questions or clarifications or something else. There is some question from all of them. Actually, Anton comes from Lund University, while the other authors from, please help me.
I am from Lund University, then Anton.
Okay, great. The paper is a software Axis. Okay, thank you. The paper is a software engineering in practice paper, so it has a practical application for the software industry, I suppose. Do you have some questions? Okay, no question from the audience. I'll play the role of icebreaker. I'm sure that when I formulate my question, a lot of other questions will come from the audience. You talk about program analysis. I know that program analysis is a wide and maybe wild research field. Said that, can you justify why did you focused on three-quarter principles and not else?
Yeah, so this was the leading example for us, and it was a good place to start for this project, I guess.
Why it is the good place to start?
Yeah.
I mean, so in the previous study for the tricoder system, the feedback loop that was created with this system was kind of showing how the feedback from the usage could actually be acted upon quicker in terms of how that was written up, the experience from that study. So that was an inspiration and sort of to see, well, this seems to be a viable way to set up such a feedback loop that is to a large extent missing. So this is kind of the setting for why this was interesting to us to explore in a different context.
So you are saying that the next future, as future research, you plan to focus your research on different kind of principles, right? Okay. There is some other question from the audience. No one. I prepared only 2 questions, so please help me. Help your session share. My second question is, if I well understood, you're focused on a company and then performed a replication in another company. This was I see in your presentation. You wrote in your last slide of the presentation, or at the end of your presentation, that results were mostly confirmed. I was wondering what are, if any, the differences in the results observed in both companies. So I am not interested in the similarities, but in the difference, because I suppose that this is a very relevant aspect for the research, for your research, of course.
Yeah, one of the differences was that we didn't use any fixes that we could apply. So we didn't get as many positive, active responses to the comments. And this kind of led to the not useful rate looking a bit different. Yeah. And yeah, of course, the social, cultural, technical culture is different, and the size of the companies are different. Yeah.
Do you have something else to add, Emma or David?
I actually, it froze for me just in the middle of the question a little bit. I missed a little bit. Are you talking about the context difference or the difference in the implementation of the approach?
Result difference.
Result difference. Well, we did see, so if looking at the numbers reported for the Track system, the sort of external numbers, there the user engagement is fairly low, especially for linter comments. We had higher sort of user engagement and kind of computing it in the same way for both systems as far as we have numbers. And but it's and that's interesting, we think, but we're also in an early stage. I think that's important in this. It's a fairly short experiment for this deployment. A lot of new analyzers coming out with a lot of things to tune. This may be quite different if you have well-tuned sort of analyzers coming out. And also sort of depends on what kinds of analyzers. So it's different if you look at linters rather than more sophisticated analyzers. So that's something that it's kind of, as you're trying to understand what's going on with that user engagement, I think that's one thing we're seeing as a difference. But we're kind of acknowledging that we're early in the development, and we can only say sort of something about that stage if we were to run it for a longer time, which we want to do. We'd kind of would be interesting to see how this develops over time.
Okay, I think that the different deep analysis of the difference can help you to better plan future work, future extension for your research. Okay, in the audience there is Miroslav Staron. Hi, Miroslav. It is a long time that I don't see you. And Miroslav, congratulate with you for the great work. And the question is, how much tool specific is this? Would it work for MS Team Server 2? I think that
Yes.
David could help to. David is here. Okay, you have about 2 minutes to answer.
Yes. So first of all, I don't know in which spot in the tool chain MS Team Server would fill really. But we tried to make it like tool stack agnostic, so that you could write integration for different tools. That was one of the main goals, that we could move it out of the context of just one company.
I can add, I'm not familiar with this tool very much, but if it's a different kind of code review tool, or if it's a different kind of an analyzer, definitely it's a matter of having a different kind of integration point, a different kind of code review tool. Definitely you could do, kind of add that as a different piece in the system. And that was very much part of the goal, designing it that way, as well as changing your execution environment from Jenkins to something else is also definitely doable.
Okay, some other question from the audience. Okay, great. So Miroslav is mostly happy with your answers. You assigned also a kudo. So great job. We have 1 minute to spend together. I prepared only 2 questions, so I cannot provide another questions. Is there someone in the audience that would help the session chair? Okay, I have a short question for you. What do you plan to extend your research? What is your research future work for you? What is the most important research work, future research work for your work?
Should I say something, or David is?
It's not here.
You can't hear me?
We can hear you, but we can't see.
Okay, I'm currently one of the super new pieces that is about creating, add the possibility to
3 seconds.
use the